In this video, we're going to do the last free response for Chapter 9 and 10, labeled 2001, number 5. And so in this problem, I will let you read this paragraph, but they're trying to test the difference between name brand and generic brand. And so it says that the group randomly selects, I'm going to go ahead and circle random because I know I'm going to be looking for it later. Selected 10 different pharmacies in a large city and filled 2 prescriptions at each of these pharmacies, one from the name brand and one from a generic brand. And the consumer group's laboratory then tested a randomly selected pill from each prescription to determine the amount of active ingredients in the pill. The results are given in the following table. So based on these results, which should the consumer group's laboratory report about the difference in the active ingredient in the 2 brands of pills? Give appropriate statistical evidence. So they're wanting you to, anytime it says give appropriate statistical evidence, they want you to do a significance test. And so what are we comparing is we're comparing the difference. So this is one where it's like matched pairs, right? And the name and generic are paired by the pharmacy they came from. So this is not 2 samples t-test. This is actually going to be a paired t-test. Paired t-test. So if you're going to do a paired t-test, if you're looking in your notes, your original notes, this was at the end of chapter 9. But the first thing you have to do is go find all those differences that we're trying to compare. So we'll just do it in order that we have it here. We'll do name brand minus generic brand. So this one would be -1. This one would be 4. This one would be 5. This one would be 13, 0, 7, 5, 8, 9, and 16, if you subtract each one. So this difference is now my sample, okay, because I'm comparing this difference number. So it's one sample using these difference numbers. And so let's just go through and do state plan, do conclude. So when you're doing a paired t-test, what parameter are you using in your hypothesis? It's the mean of the difference numbers. So we call that mu d, and we'll define that to be the mean difference, or I can even say mean of the difference of the active ingredient and then you can either write it out in words when subtracting, or just make sure you define what order you did your difference, because you don't have to do name minus generic, but if you did generic minus name, that would switch these signs, which would be fine, but everything's going to look opposite in the problem. So tell them what you did. We're doing the mean of the name minus mean of the generic. And we can just leave it at that. And so then our null would be, remember that there's no difference, that the mean of the difference is 0. And then do we have reason to believe that one is larger than the other? We're just trying to determine, is there a difference? It doesn't give us some direction that the difference might be, so we're just trying to see, test, is there a difference? Is it not 0? And then our alpha would be 0.05. So then our plan, we already said it here, it's a paired t-test. I'll go and write it again. But you're not going to see that in your calculator. That's like a 1 sample t-test, which in your calculator, you would just go to t-test. It doesn't say 1 sample. And so then we're going to check our conditions. So what was random? We know that it said they randomly selected the pharmacies, and they also said that they randomly selected the pill. So I'll say random selection, because your sample was I would say the pharmacy. So I'll say random selection of pharmacy and 10%, we can say assume at least how many would we need? 100 pharmacies in our population. That way our sample is less than 10% of our population. And now for normal. Our n is not greater than 30, right? Our n equals 10. Oops, there it goes, 10. So CLT doesn't apply because it has to be greater than 30. So then what do we have to do is we have to actually graph it and check for skewness or outliers. So if I was thinking ahead, I would have already done this, but I'll show you in case you forgot. I'm going to actually make a new document, and then I'm going to go to list and spreadsheet, and I'm typing in the difference. Remember, don't forget that's your sample. So I'm going to label that just X, and then type in these numbers. You have to type in the 0. Why did I put 10 there? That's 16. That's weird. I don't know. And now what we can do is you go to Control I to get a new page, and then you go to Data and Statistic, and then I'm going to put the X, whatever I label, on my X-axis. And if you wanted, you could do a dot plot, or if you think it's easier to draw a box plot, you can go to Plot Type, Box Plot, and draw that box plot. And so then we can see that there's not strong skewness or outliers. So you have to sketch that, and you need to actually put like the numbers on the X-axis. So I'm going to go from, I'll put 0 close to the end to 16, which that doesn't make sense because 6 would not be in the middle. I'm going to make this actually go to -2. And so our box goes from 4 to 9. So we'll say 4 to 9. And our median line is at 6. And then this goes to 16. And this goes to -1. And then we can say, no, I did not scale that good, as you can see, but hopefully you would scale that better on your actual AP test. And then we can say no strong skewness or outliers, so approximately normal. So now we can go do our do. Let me get a different color. Which is nice because now we've already typed our data in our calculator. So to do it in the calculator, you would just push Control I again, go to Add Calculator. You're going to go to Menu, Stats, Stats Test, and we already said a paired t-test is a 1 sample. You just go to t-test. As you can see it, there's not a glare. And now we did type in our data this time, so we're going to keep data. Our mu 0 is set to equal 0, right? Our list is X. What is mu 0? I didn't really describe that. That's whatever you set your null equal to. And then keep your frequency list 1. Our alternative is just not equal, so I'm going to keep that. And here is our information. So our t-value, our test statistic, is what that is called, is 3.956. Our p-value is 0.0033. Our degrees of freedom is 9, which that one makes sense. And we don't, did I write down my n anywhere? I wrote it up here, so you should be good to go unless you just want to write down everything to be careful. And so then you also need to draw your distribution. 0's in the middle. The standard deviation is not 1 though, because it is not a z distribution, it's t. So we're going to put 3.956 and shade. This is a two-tail, right? So you shade in that tail, and then you go to the opposite side and you go to the negative version, negative 3.956, and you shade in that tail as well. So both these areas together is already 0.003, so really that should be even more out than I did. So now we're ready to conclude. Oh, I don't want to use that marker because it's dying. And hopefully you can do this one, but let's make sure we're good. So we would say since p-value of 0.003 is less than alpha equaling 0.05, we reject HO and do have convincing evidence that our HA, the mean difference, is not 0. The mean of the difference is not 0. So let's make sure we answer their question, because that's kind of like ambiguous. What is that? So what does that mean? If the mean is not 0, then that means there is a difference. And I'm going to put so there is a difference in what? What were we talking about? In the active ingredient. Ingredient in the 2 brands of pills. Right? What I did is I started just answering their question, repeating how they worded their question. So it might help when you're doing these. This means no difference. If the mean difference equals 0, if it's not 0, then there is a difference. That means when you're putting it in words at the end. Okay, so always, always, always make sure you do your normal conclusion just to make sure you don't miss anything. And then you go back, and if your normal conclusion didn't seem to really answer the original question, add a little bit more. So what does that mean for their original question? Okay, that's not always necessary, but just read it and make sure you encompass everything you were wondering about. So hopefully that helped. If you need anything else as you're working, please let me know.